Greetings, everyone. Learning is a hobby here. It's been a while, but I want to go over my summary for chapter 4 in Peter Smith's An Introduction to Formal Logic. So I'm trying to get through, uh, if you've been following along with my logic series on the channel, I've been trying to get through up to chapter 8 in this book before I get back to the book by Copy and by Bergman. So this is chapter 4, which is on proofs. Let me bring up my summary and we'll go over it. And while I'm doing that, let me just mention um, I don't think I'm going to go over uh, on the channel at least. I'm not going to go over the solutions to the exercise set for this section because I'll post a link to this down below. Um, Peter Smith has all the solutions to the exercises printed out that you can print out as PDFs on his website. So I'll post a link to that if you want to look at that. But they're really, I just don't think there's a reason for me to actually make a video on the solutions because he already has them in full detail out on his channel. But that doesn't mean that you shouldn't try them first before looking at the uh, the solutions because you should. That's really the only way to learn is to do the problems, and then once you've give them a good shot, then you should look at the answers just to check if you've understood the problems correctly. So anyway, that's an aside. Here's my summary for the chapter. Um, like I said, this chapter's on proofs. How can we establish that a not obviously valid inference is in fact valid? One answer is by giving a multi-step argument that takes us from the inference's premises to its conclusion by simple, plainly valid steps. In other words, by giving a derivation or a proof. Okay, and here's some examples. Argument A says babies are illogical. Nobody is despised who can manage a crocodile. Illogical persons are despised, so babies cannot manage a crocodile. And apparently, this argument is by Lewis Carroll um, of Alice in Wonderland fame. He was also a mathematician and a professor, also, if you don't know. Anyway, this is a valid argument. Consider the following two-step derivation. Right, so this is A prime. This is the formally laid out argument. Premise one, babies are illogical. Premise two, nobody is despised who can manage a crocodile. Premise three, illogical persons are despised. And now we have our inference steps. So the inference step from 1 and 3 gives us babies are despised. So in other words, babies are illogical, illogical persons are despised, implies babies are despised. That's a syllogism, right? And then finally, the conclusion, five, babies cannot manage a crocodile, comes from the inference from 2 to 4. Sorry, from premise sorry, from premise two and proposition four. So two says nobody is despised. You can manage a crocodile. Four says babies are despised. Therefore, babies cannot manage a crocodile. All right, and notice that both of those intermediate inference steps are valid. The inference from two of the premises to the interim conclusion, four, and then the second inference from the other original premises and the interim conclusion, four, to the final conclusion, five, are both evidently valid. We've seen inference steps like that already in this book and in the other books that we're looking at too. All right, here's another example. This is argument B. Everyone loves a lover. Romeo loves Juliet, so everyone loves Juliet. Okay, take premise one to here. We need this in order for the argument to go through. Take premise one to mean everyone loves anyone who is a lover, where lover is by definition a person who loves someone. Then this argument is also deductively valid. Here's a multi-step derivation. Okay, so premise one, everyone loves a lover. Premise two, Romeo loves Juliet. And then we get an inference from two. That means Romeo is a lover because Romeo loves someone, right? Then from 1 and 3, we get the inference step, everyone loves Romeo. So in other words, everyone loves a lover. Romeo is a lover. Therefore, everyone loves Romeo. Excuse me. We get another inference here for proposition 5. Juliet loves Romeo. That comes from 4 because everyone loves Romeo. Juliet loves Romeo. Juliet's part of everybody, right? And then again, we get another inference here from 5. Juliet loves Romeo implies Juliet is a lover because she loves somebody. And then finally, the conclusion, everyone loves Juliet, is inferred from from premise 1 and proposition 6. So 1 says everyone loves a lover. 6 says Juliet is a lover, therefore everyone loves Juliet. Okay, so when it's not written out in this formal, step-based argument, this might not be it might not be clear on first glance that this is a valid argument, but indeed it actually is. If you use the definition of what a lover is that the author gives here. Okay, note that each small inference step is valid. In other words, truth preserving. One way of demonstrating that an inferential leap from some premises to a given conclusion is valid is by breaking down the big leap into smaller inference steps, each one of which is clearly valid. Right? A multi-step argument put together in such a way as to form a deductively cogent derivation is called a proof. Deductively cogent means that it's valid. The inference step is valid to the conclusion. Just like one-step arguments can be merely valid, deductively cogent valid means deductively cogent, they mean the same thing, or they can be sound, deductively cogent, and proceeding from true premises. The same distinction can be made about multi-step derivations slash proofs. There is no separate term for a multi-step argument that is valid versus sound. They are both called proofs, but context should make it clear what kind of proof we are talking about. And only sound proofs establish their conclusions as true. All right, next section in chapter 4, fully annotated proofs. We can explicitly indicate what type of form of inference move is being invoked at each stage of a derivation. For example, let's label the following forms of inference as R and S. So R is the inference no F is G, N is F, so N is not G. 5 is the inference no F is G, so no G is F. Right, these are valid inferences. Then consider this argument here. C, um, no logician is bad at abstract thought. Joe is bad at abstract thought, so Joe is not a logician. Right. Well, C hardly needs a proof. We can prove it by invoking R and S as follows. So here's the formal proof, which we're labeling C prime. All right. Premise 1, no logician is bad at abstract thought. Premise 2, Joe is bad at abstract thought. And then we have the inference from premise 1 by the inferential form S, that no one bad at abstract thought is a logician. So that follows directly from 1, and using inference step S. And then finally, from 3 and 2, we can infer proposition 4 by the inference form R. Joe is not a logician. So that follows from no one bad at abstract thought is a logician, and Joe is bad at abstract thought, therefore Joe is not a logician. All right, it's difficult to give strict rules for doing this sort of thing, which is one good reason to eventually move away from arguments in messy English to considering their counterparts in more rule-governed, formalized languages, which is something I'm more comfortable with being a student of mathematics. Of course, the validity of C has nothing to do with its content, abstracting from its premises and final conclusion. Abstracting from its premises and final conclusion, any inference step of the following type is valid. So this type that the author calls T is valid. No F is G. N is G, so N is not F. Any inference of this pattern can be shown to be valid using a proof parallel to C prime. In other words, the general reliability of T follows from the reliability of R and S. And the author says later on in the book, we'll explore how principles of inference hang together. Okay, here's another example from Lewis Carroll. This is argument D. Anyone who understands human nature is clever. Every true poet can stir the heart. Shakespeare wrote Hamlet. No one who does not understand human nature can stir the heart. No one who is not a true poet wrote Hamlet, so Shakespeare is clever. Okay, and just a note here, any inference step of either of the following two types is valid. So inference U, any slash every F is G, N is F, so N is G, and inference V, no one who isn't F is G, so any G is F. If you want to wrap your head around these, because sometimes the English can be a little confusing, for me, it helps to write down the set relations between everything. Um, so just a bit of advice if like for example, no one who isn't F is G can be kind of hard to parse though, from the English. So what I would suggest is drawing a Venn diagram or something and it should be clear what it's saying. Anyway, let's continue here. Then we can argue as follows. D prime, premise one, anyone who understands human nature is clever. Premise two, every true poet can stir the heart. Premise three, Shakespeare wrote Hamlet. Premise four, no one who does not understand human nature can stir the heart. And premise five, no one who is not a true poet wrote Hamlet. And then we have some inference steps here from the inference patterns V and U. So from five, anyone who wrote Hamlet is a true poet by five. I'm sorry, not by five, by V. And then Proposition 7, Shakespeare is a true poet, follows from inference pattern U from 6 and 3, from Proposition 6 and from premise 3. Um, Proposition 8, Shakespeare can stir the heart, follows from premise 2 and Proposition 7 by the inference pattern U. Right, and on here. Proposition 9, anyone who can stir the heart understands human nature, follows from premise 4 by inference pattern 5. Proposition 10, Shakespeare understands human nature, follows from Proposition 9 and 8 by inference pattern U. And then finally, the conclusion, Proposition 11, Shakespeare is clever, follows from premise 1, and Proposition 10, again by the inference pattern U. Thus, D is deductively valid. Okay, so this is we've now seen some examples where we're writing down formal proofs here. And now we want to go to section 4.3, which is titled Glimpsing an Ideal. So an ideal meaning something to strive for, but that is not always convenient or possible. But we have now seen an ideally explicit way of setting out one kind of regimented multi-step proof. Every premise is stated at the outset and explicitly marked as such, and then we write further propositions one under another, each marked with what it is inferred from and what principle of inference is being invoked. Right, we've seen some examples of that already. Obviously, everyday arguments and even proofs in mathematics, you've seen if you've been a watcher of the channel, I do proofs, a lot of proofs on the channel, and you see I don't write my proofs in this formalized way. But so normally, when you're doing things like this in everyday practice, um, your arguments normally fall short, a long way short of meeting these ideal standards of explicitness. Now, I should say in mathematics, you can always put them into a formalized, regimented um, form, but I'm not going to go. We're not going to go there here. Uh, Faced with a puzzling multi-step argument, rewriting it into something nearer this ideal, fully documented shape will help to assess the argument. So, whether you're dealing with an argument in mathematics or science or philosophy or politics or anything like that, if you want to analyze someone's argument for something, or you want to attack someone's argument for something, then restructuring it or rewriting it over in this formal step-based proof system will help you analyze or see all the pieces of the argument and how they fit together. An explicitly annotated proof gives a critic a clear target to fire at. So to reject the conclusion, one must either one, rebut one of the premises, two, show an inference step does not have the claimed form, or three, come up with a counterexample to the reliability of one of the forms of inference that is explicitly called on. So that's these are ways to attack an argument. It's made easier if it's in this structured form, right? If the premises are agreed and if the and the inference moves are uncontentiously valid, then the proof will establish the conclusion beyond further dispute. The exercise of regimenting an argument into a more ideally explicit form will reveal one, redundancies, so premises or inferential detours that are not needed to get to the conclusion, and also two, which is important as well, suppressed premises, meaning premises that are not stated but which are needed to get a well-constructed proof. Arguments with suppressed premises are called enthememes. We've mentioned this before in my notes for copy and for Bergman. All right, consider this argument E. Excuse me. The constants of nature have to take values in an extremely narrow range, or in other words, have to be quote unquote fine-tuned to permit the evolution of intelligent life. So the universe was intelligently designed. This is an argument that you may have heard for. It's called the fine-tuning argument. Um, I I think this is a flawed argument, but anyway, the author says this: there are unspoken assumptions in the above argument. There's two suppressed premises here. One, intelligence has evolved, which is uncontroversial. Intelligence has a lot of empirical evidence and theoretical justification for it. Um, Two, two, intelligent design is needed in order for the universe to be fine-tuned, and that premise is more problematic. It is not clear or established, I think, at all that intelligent design is needed or is necessary for a universe to be fine-tuned. Okay, Section 4.4, deductively cogent multi-step arguments. When is a multi-step argument internally cogent? And the answer is when each inference step is cogent and the steps are chained together in the right way. And we'll talk about what the right way means in a few minutes. So consider this argument F. All right, premise one, all philosophers are logicians. And then uh, we infer, I'll put that in quotes because this is not a valid inference step, from one that all logicians are philosophers. This is obviously a fallacious inference pattern because you can argue for nonsense with it. So in other words, one might just as well argue that all women are human beings, hence all human beings are women. Right, here's another bad argument, which the author calls G. Right, premise one, all existentialists are philosophers. Premise two, all logicians are philosophers. And proposition three, all existentialists are logicians, follow or are inferred, in quotes, from one and two. This is, again, a bad inference. This does not follow. One might as well argue that all men are human beings, all women are human beings, therefore all men are women. Right. So this example here is an instantiation that invalidates this inference pattern. Okay, now imagine someone claims these two bad inferences together. Sorry, chains. So now imagine someone chains these two bad inferences together into a two-step argument, which here he's calling H. Right? Premise one, all existentialists are philosophers. Premise two, all philosophers are logicians. Then proposition three, all logicians are philosophers, follow from inference F and premise two. I follows, again in quotes. And then proposition four, all existentialists are logicians. Again, the inference here that's being labeled is similar to the inference pattern G. If you consider premise one and proposition three. Again, this really doesn't follow in because G is not a valid inference step. But notice that this argument actually is valid, just not with the intermediate inference steps that's labeled here. So, for example, you get a syllogism here. Uh, if you use premise one, all existentialists are philosophers, and premise two, all philosophers are logicians. This proposition four follows validly from those two um, premises there. But anyway, here's what the author says. Notice that despite the bad intermediate inferences, H4 really does follow from H1 and H2. If all existentialists are philosophers, oh, this is what I just said. So, it's a valid syllogism if you consider premise one and two. Four follows validly from that. It's a valid inference step. Okay, to avoid H being considered a cogent proof, we require a deductively cogent multi-step argument, not only to have the leap from initial premises to final conclusion be valid, but that the individual inference steps along the way also be valid. So you need not only the big inference step from premises to conclusion to be valid, but all the intermediate inferences have to be valid as well. Okay, so consider this argument I. Premise one, Socrates is a philosopher. Premise two, all philosophers have snub noses. And then proposition three, which follows from one and two, Socrates is a philosopher and all philosophers have snub noses. This is should be trivially obvious, right? Obviously valid. Um, and we have another obviously valid, or trivial, I guess I should say trivially valid inference step in J. All right, premise one, Socrates is a philosopher, and all philosophers have snub noses. From that follows, all philosophers have snub noses. All right, and thirdly, here is another plainly valid inference step. Here, this is argument K. Premise one, Socrates is a philosopher. Premise two, all philosophers have snub noses. And then from one and two, Socrates has a snub nose. All right. Just a note here, we can extract more than one implication from the same premises. If you look at argument I and K, if you go back in the video, you'll see that we have the same premises but different conclusions. So different conclusions can follow from the same set of premises. All right, these last three inference steps are unproblematic. However, if we look at this argument L, which I'll read out here, premise one, Socrates is a philosopher. And then proposition two, which we're inferring from one and three by inference pattern I. Socrates is a philosopher and all philosophers have snub noses. Then proposition three, all philosophers have snub noses, which is inferred from two by inference pattern J. And then from one and three by inference pattern K, we get proposition four, Socrates has a snub nose. All right, so seemingly we've proven from this argument, we've proven that the shape of Socrates' nose, we've proven the shape of Socrates' nose from the premise that he's a philosopher using separately valid steps. However, the problem with this is their circularity. So notice the circular sort of nature of that we have between proposition two and three here. All right, L2 is derived from L3 and L3 is derived from L2. This shows that there's another condition for being deductively cogent in a multi-step argument. Right. In addition to all the individual inference steps being valid, the steps must be chained together in a non-circular way. This is what we meant a few minutes back when we said that the everything has to be chained together in the right way. Right? It has to be non-circular. In other words, each step, unless a newly made assumption, must depend only on what's gone before. Okay, and then we get to section 4.5, which is on indirect arguments. Right, now we can consider indirect arguments. For example, sometimes we want to show not S by assuming S and deriving an absurdity. Right, so returning to A prime in section 4.1, how could we convince someone that the inference step, nobody is despised who can manage a crocodile, babies are despised, so babies cannot manage a crocodile is valid? All right, so we'll do that with an indirect argument. So here's the demonstration. One, babies are illogical. That's a premise. 2, nobody is despised who could manage a crocodile, also a premise. 3, illogical persons are despised. Again, that's a premise. And then we infer 4 from 1 and 3, babies are despised. And then we suppose temporarily, for the sake of argument, that babies can manage a crocodile. That's a supposition. Then we get from 2 and 5, babies are not despised. And from 4 and 6, then that's a contradiction because 4 says babies are despised and 6 says babies are not despised. That's right. Those taken together contradict each other. They can't both be true together. Our supposition then leads to an absurdity. Hence, 8, babies cannot manage a crocodile. From steps five through 7, he labels this RAA. RAA stands for reductio ad absurdum. It's kind of like a proof by contradiction. If you, I've done proofs by contradiction on the channel before, so if you watched my videos, that shouldn't be a new thing. In the above argument, we want to establish 8. However, in 5, we temporarily assumed the opposite to be true and showed that this assumption leads to something that contradicts the earlier claim 4. Therefore, 5 must be false, making its opposite 8 true. And then again, RAA stands for reductio ad absurdum. Okay, here's another example. Argument M. No girl likes any unreconstructed sexist. Carolyn is a girl who likes anyone who likes her. Henry likes Carolyn, hence Henry is not an unreconstructed sexist. One way to see that M is valid is to use a reductio argument. So let's do that down here. Right, this is M prime. Okay, premise 1, no girl likes an unreconstructed sexist. Premise 2, Carolyn is a girl who likes anyone who likes her. Premise 3, Henry likes Carolyn. Then we can infer 4 from 2 and 3. Carolyn is a girl who likes Henry. 5, which follows from 4, Carolyn is a girl. And 6, Carolyn likes Henry, also follows from 4. Right? And then we make a supposition here for the sake of argument. 7, Henry is an unreconstructed sexist. 8, no girl likes Henry. This follows from 1 and 7. 9, Carolyn does not like Henry from 5 and 8. And then finally, that's a contradiction because 6 and 9 contradict each other. Right? 6 says Carolyn likes Henry, and 9 says Carolyn does not like Henry. Therefore, the supposition leads to an absurdity. Hence, 11, Henry is not an unreconstructed sexist, which follows from the reductio argument from steps 7 through 10. Okay, here's the definition of a reductio argument. If A1 through AN as background premises plus the temporary supposition S entail a contradiction, then A1 through AN by themselves entail not S. And here's the justification. So assume A1 through AN and along with S do entail a contradiction, C and not C. Since entailment is truth-preserving, anything entailed by truths must also be true. Suppose then that A1 through AN and along with S are all true together, then C and not C would have to be true as well. This is ruled out, however, since contradictions are never true. So A1 through AN along with S cannot all be true together. Of course, simply knowing at least one of the A's along with S can't be true together doesn't tell us where the blame lies. However, in the situation in which all the A's are true, then the only thing that's left that can be false would be S. So proposition S must be the false one, hence A1 through AN entail not S. All right, and then he actually asks a question here. What happens when n equals 0 and there are no background premises? This is my answer. This is not in the chapter itself. This is my answer to his question. Since S itself entails a contradiction and a true proposition can't entail a false proposition, S must always be false. Therefore, its opposite, not S, must always be true. Okay, reductio ad absurdum arguments are an example of an indirect argument. We take a sidestep via some temporary supposition. There are also other kinds of indirect arguments that we'll see later on. The author says, in addition to ordinary valid inferences, we must now allow inference steps like reductio ad absurdum. In an indirect argument, to suppose some proposition is true for the sake of argument is not the same as asserting its truth. So propositions, the ingredients of arguments, do need to be distinguished from outright assertions. Propositions can be asserted, supposed, rejected, wondered about, and more. Okay, and then finally, the availability of indirect modes of inference complicates the story about what makes for a deductively cogent multi-step argument, but we'll return to this later on in the book, says the author. And that's my summary for chapter 4. All right, let me stop the screen share. Okay, so like I said, I'm in the middle actually of doing the exercise set for chapter 4, but I'm not going to post my solutions to it here because, like I said, the author has the solutions already posted on his websites. But I will post a link to that down below if you want to check your answers when you try the problems. Um, so let me know what you guys think. I have a few more videos coming out that I'm going to record after this because it's been a while since I've made some videos. So I'll see you then. And until that time, keep learning, everybody.